Good morning, sir. I'm Chandana from the Department of Computer Science and Engineering. Today, I'm going to explain about allocation methods from the subject operating systems. Uh, Let us move into the topic. First of all, I'm going to explain about the introduction to allocation methods. Allocation methods are essential for managing system resources. They determine how memory and processing power are assigned to various tasks. Understanding these methods helps in the optimizing system performance and resource utilization. Next, I am going into the topic and what is resource allocation. Resource allocation refers to the distribution of system resources among processes. Efficient allocation is crucial for maximizing throughput and minimizing response time. It involves various strategies that can impact overall system efficiency. Next, I'm going into the types of resources. There are many types of resources like floppy disk, ROM, hard disk, and CPU, CDs, and RAM, etc. are the more of resources we use. Resources can include CPU time, memory space, and input and output devices, and network bandwidth. Each type of the resource may require different allocation strategies to optimize performance. Understanding resource types aids in the selecting appropriate allocation methods. Next, I'm going to explain the fixed partitioning. Fixed partitioning divides the memory into fixed state segments, like each process is assigned to a partition regardless of its size, which can lead to fragmentation. This method is simple but can be inefficient due to unused space in the partitions. Next, I'm going into explain the dynamic partitioning. First of all, algorithms for partition allocation are divided into three types: first fit algorithm, best fit algorithm, and worst fit algorithm. Dynamic partitioning allocates memory based on the size of the process. This method reduces the internal fragmentation but can lead to external fragmentation. It requires a more complex memory management to handle varying sizes. Next, I'm going into the topic of paging. Paging is divided into fixed size blocks called pages per allocation. Next, it eliminates external fragmentation by allowing non-continuous memory allocation. Pages can be easily mapped to physical memory, simplifying memory management. We can see the examples of paging like this. Frames like this. Frames are directly moved into the main memory. Pages are first moves into the secondary memory. Next, segmentation. In this, how the segmentation is formed in the allocation methods. Segmentation divides memory into variable sizes segments based on the logical units. Each segment represents a different logical entry, such as function or an array. This method provides a more natural way to manage memory but can be complicated allocation. Next, I'm going to explain the resource allocation graphs. We can observe the graph with a cycle but no deadlocks. Here we can observe the particular graphs. Resource allocation graphs illustrate the allocation of resources to processors. They help in the visualization, potential deadlocks, and resource contention. By analyzing these graphs, system can implement strategies to prevent deadlocks. Next, I'm going to explain the allocation strategies. We all know the allocation strategies are three types: first fit, best fit, and worst fit. Common allocation strategies include first fit, best fit, or worst fit. These are the common allocation strategies. First fit allocates the first block of the memory that is large enough for the process. Best fit tries to maximize the waste by allocating the smallest available block, while the worst fit allocate the largest block. This is the conclusion of our topic, allocation methods, and the future trends also included in this page. Allocation methods are vital for efficient operating system performance. Emerging technologies like cloud computing and virtualization demand adaptive allocation techniques. Continuous research is needed for the needed to improve allocation methods in increasingly complex systems. This is the some information about the allocation methods, how we manage the allocation methods, and how it is important in the operating systems. At last, thank you for giving this great opportunity to me, sir.